The goal of rapid prototyping is a zero-friction workflow. You describe a part in plain English, and your 3D printer starts producing it immediately. Currently, even small design changes are slowed down by heavy software suites like Fusion 360. Opening a massive application and navigating complex sketch menus just to change a single dimension creates a constant bottleneck for simple iterations. Early 3D AI models tried to solve this, but they focused on visual aesthetics over mechanical logic. They produced non-manifold, blobby meshes that were full of impossible geometry, making them impossible for slicing software to turn into a printable file. In hardware engineering, speed is only useful if the part maintains exact mathematical dimensions. If a bracket won't fit a standard bolt, the AI has failed. CADAM is an open-source web application designed to address this specific problem. It targets the gap between the flexibility of AI and the rigid requirements of mechanical engineering.
The project treats 3D models as pieces of engineering rather than digital art. It restricts the AI to specific, constrained outputs that follow the rules of physical manufacturing. By focusing on code-based geometry, the application aims to move the design process away from manual drafting and toward a language-based workflow. CADAM achieves dimensional accuracy by ignoring pixels and polygons during the generation phase. Instead, it uses AI to write literal, executable code. Your text prompt goes to Anthropic's Claude API, which returns an OpenSCAD script using mathematical coordinates to define 3D shapes. That script executes directly in your browser via WebAssembly, compiling entirely on your local hardware instead of a distant cloud server. Because the heavy lifting happens in the browser, the model renders instantly. There is no waiting for large files to upload or download. Since the model is built from code rather than digital clay, the geometry is always manifold.
The resulting file is structurally sound and ready for the printer immediately. For real-world engineering, static models aren't enough. You need to fine-tune. CADAM provides parametric sliders. The app scans the code for variables and automatically creates sliders for dimensions like hole sizes and wall thickness. Moving these sliders updates the model in real time, letting you dial in exact tolerances without writing a new prompt. The AI handles the repetitive task of writing the initial script, but the engineer maintains final control over the exact dimensions. While this workflow is fast, it is important to understand the technical constraints currently documented in the project's development. According to GitHub issue 65, the tool is strictly for geometric objects. Because it relies on the mathematical logic of OpenSCAD, it cannot generate organic shapes like character models or complex biological forms. Additionally, developers have noted in issue 75 that the image-to-3D feature is currently unstable on the demo site. For the most reliable experience, you should rely on text-based descriptions. Knowing exactly where these mechanical boundaries sit is what allows a designer to actually integrate this tool into a professional project. This raises a larger question for the maker community. Will code-driven generation become the standard for mechanical design, or will visual drag-and-drop interfaces remain the preferred choice for engineers? To stay updated on the latest rapid prototyping tools and open-source hardware, make sure to subscribe. To see how AI is being used to coordinate complex robotic systems, watch our breakdown of modern robotic pipelines here. Thanks for watching.